Hi friends, welcome back to Acharya Gurukulam. Today's topic is Navi-based algorithm in machine learning, a civil engineering application. In this video, I'm going to discuss about introduction and two solved example problems I'm going to discuss in this video. One is discrete features and the other one is continuous features. What is Navi Bayes? Navi Bayes is a machine learning classification algorithm that predicts the category of a data using probability. It assumes that all features are independent of each other. The main idea behind the Navi Bayes classifier is to use the Bayes theorem to classify data based on the probabilities of different classes given the features of the data. The main equation to be used for Navi-Bayes algorithm is P of A given B is equal to P of B given A multiplied with P of A divided by P of B. P of A given B is posterior probability. P of B given A is likelihood, and P of A is prior probability of class A. P of B is marginal likelihood. A schematic diagram of Navi-Bayes algorithm is shown here during the training phase and the prediction phase. What are the various advantages of Navi-Bayes algorithm? It is simple and easy to implement, and it does not require as much as training data, and it handles both continuous and discrete data that we are going to discuss with one example, civil engineering related example. And it is fast and can be used to make real-time predictions, and it is not sensitive to irrelevant features. Now let us discuss about the discrete method. Given data from the site observations, that is groundwater, soil type, and relative density, classify whether the soil at a site shallow, sand, and loose. With these conditions, we have to like quantify whether the soil liquefies or not. So for that, a tabular column is given with the ID 1 to 10, and the status of the liquefaction either yes or no, and the groundwater is given shallow and deep, soil type sand, clay soils, and relative density loose and dense. Now with this data, first we need to calculate the probability of each and every classification of groundwater, soil type, and relative density. And with that data, we have to classify with the shallow groundwater, and sand soil type is sand, and relative density is loose. With these conditions, we have to estimate whether the soil liquefies or not. The total number of counts n is equal to 10, and the total number of yes from the table, if you go to the table, and the total number of s are 1 2 3 4. So four numbers are yes, and remaining six number are no. So what are the IDs for four? That is 1 2 and 5, 1 2 5 and 8 in a tabular column, and no category 6. The IDs are 3 4 6 7 9 and 10 from the table. Now for calculating the prior, what is the probability of yes with the given data? So the probability of yes is equal to the number of values in S category, that is 4, divided by the total number of values, that is 4 by 10, which is 0.4. And for probability of no, which is equal to 6 by 10, and that is 0.6. Now the step A or step 1 is to estimate the conditional probability. So for each category, the feature value X and class C, we need to calculate the uh, probability of X given C using the equation, that is which is equal to count of X comma C plus 1 divided by NC plus K, where k is the number of distinct values of that feature. Here k is equal to 2 to binary feature. So why it is k is equal to 2? Because it is two classifications which is given in the tabular column, and compute for each and every feature. Let us take the first case, that is the case 1, that is a groundwater category. So under this category, we have two classifications. One is shallow, the other one is deep. So among four samples, yes, in the category of S, so the shallow are 4 and deep is equal to 0. So now if you go to the tabular column, so what are the values? What is the classification for S category? For S, you see shallow, and yes, shallow. Here also shallow. Here also shallow. So that means for the classification of D, for the classification of deep, the liquefaction status is equal to no. For Okay, so among four, the four samples, shallow is equal to 4 and deep is equal to 0. Now, what is the probability of shallow for S, which is equal to, based on the equation given in the previous slide, that is a count of x comma c. So the count of x comma c is 4, that is a shallow, because we are calculating for shallow. So shallow plus 1, go to the equation, plus 1 divided by nc plus k. So NC is the number of counts plus K is equal to 2 in this problem. So that is 4 plus 1 divided by 4 plus 2. So 5 divided by 6. It is equal to 0.833. Similarly, probability of D given S is equal to, for D, we don't have any classification under groundwater. So that is deep is equal to 0. 0 plus 1 divided by 4 plus 2, which is equal to 0.166. Now similarly, we have to calculate for no category. So for no category, the total number of samples are 6, and out of which shallow value, out of which shallow is equal to 0 and deep is equal to 6. Now we need to calculate the probability of shallow given no, which is equal to, because for shallow we don't have any data, so the total count is equal to 0 plus 1 divided by 6. So this 6 is the number of features in the no category. 6 plus 2, which is equal to 0.125. So similarly, probability of D given no, which is equal to 6. So this 6 is for the case of deep. So 6 plus 1 divided by 6 plus 2, which is equal to 0.875. Similarly, we consider another case, that is a soil type. So under soil type, it is classified as sand and clay. So similar calculation you have to perform for the case 2 also. So among S, the total number of values are 4, and the sand, out of which sand is equal to 4 and clay is equal to 0. So calculate the probability of sand given S, which is equal to 4 plus 1 divided by 4 plus 2, which is 0.833. Similarly, for clay also, the value is 0.166. Next, among no category, the total number of samples are 6 samples, out of which sand are 3 and clay also 3. So for that, we calculate the probability of sand given no, which is equal to 3 plus 1 divided by 6 plus 2, which is equal to 0.5. Similarly, probability of clay given no, which is equal to 3 plus 1 divided by 6 plus 2, which is equal to 0.5. Then similarly, we have to perform the relative density. Under relative density, it is classified as loose and dense. So similar calculation shall be performed for the relative density also. Then classify a new site. So far the probabilities are calculated for all the features which are given in the table. Now we need to classify a new site. So the new site, the observations are groundwater is equal to shallow, soil type is equal to sand, and the relative density is equal to loose. So with these conditions, we have to tell whether the site, new site liquefies or not. So for that, we need to estimate the score for S, the score for no. So the equation is given here. Score of S is directly proportional to probability of S multiply with the probability of shallow given S, multiply with probability of sand given S, multiply with probability of loose given S. Similarly, for no classification also. then you calculate score of S, which is equal to what is the probability of S. So these probabilities are already calculated in the earlier slides. Just multiply with the given values. Probability of S, that is 0.4. Probability of shallow given S 0.833. Probability of sand given S is 0.833. Probability of loose given S is 0.833. After multiplying all these values, then it arrives 0.231. Similarly, score of no is equal to probability of no multiply with probability of shallow given no multiply with probability of sand given no multiply with probability of loose given no. So probability of no is 0.6, probability of shallow 0.125, probability of sand 0.5, and probability of loose 0.125. After multiplying, then we'll arrive 0.00468. Now, out of these two, the score of S is greater than score of no. So that means it predicts the liquefaction the status of the liquefaction is yes. So that means with the given conditions, groundwater is equal to shallow and soil type is sand and relative density is loose. With these conditions, the soil liquefies. So that is what is the output from this example.